Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the NPV function in Excel to find the net present value, NPV for short, for a capital budgeting question. In any intro finance class and more advanced ones, you will have a unit on capital budgeting, and we professors will always have questions where we give you a schedule of cash flows for an investment project and ask you to use a decision rule, like the net present value, to determine if the project should be started or not. If you want to ace those questions, this video is for you. So I prepared a standard question here asking us to find the NPV, the net present value, for this proposed project of my company building a warehouse. And for any capital budgeting question, regardless of what you're looking for, it's best to convert this verbal description into a cash flow schedule on a timeline, which I have already prepared for us. So year zero is usually going to always be a negative value. It's going to be some sort of initial expense. And for us, it's an initial expense of 400,000. So you put in negative 400,000 for year zero. And then for years 1 through 5, I'm going to enter in the positive cash flows that the warehouse is going to generate for the company. And 100,000 is year 1. 120,000 is year 2. Oop, that's 1.2 million. That's too much. It's generally good to have it formatted so you have these commas and periods and such so you can quickly see if you've entered the number correctly or if you've had too many zeros or too few. I had too many there. 125,000 for year 3, 130,000 and 135,000 for years 4 and 5. So this is our schedule of cash flows, which we'll be using in the function. We also need a discount rate for the project. Most of the time you'll be given this. Some more advanced problems you'll be solving the WACC yourself, which is kind of beyond the scope of this sort of video. So we're given the WACC. It's 12%. Make sure it's an actual percentage here. Don't just put in 12. And now we're going to go to our cell next to NPV and type equals NPV, open parentheses. So Excel is helpfully displaying the parameters we need to enter into this function. The first one is rate. This is our interest rate. So our interest rate is the WACC. It's that 12%. We could enter in 12% or we could use cell references. I'm going to use cell references because that's better practice in Excel. And we would just either click on B8 or type in B8 and Excel will just draw from whatever we entered as our WACC. Now we go comma, and we're entering values. We only have to enter at most 1. The brackets there just mean value 2, value 3 are optional. Here we're going to enter much more than just one value because we have a whole schedule of cash flows. And be careful here. The NPV function doesn't start at year 0. It starts at year 1. That's why it's called value 1. That might help you remember. So we want to start here. And we can just click and drag across, and it'll give us an array C6 colon G6. I could have also done C6 comma D6 comma E6 comma F6 comma G6, but that would have been a lot. And this is all we need for the NPV function. And this will give us the present value of these 5 cash flows all at year 0. But note it's not going to include year 0. So in order to have the right answer, we need to do a second step, which is adding B6 here, the negative 400,000, along with the NPV function. And now we get a positive 33,141 as the net present value of this proposed project. I did this all in one cell, as you can see right here. If you find it easier to just do the NPV and then in a separate cell subtract off the 400,000, that will work just fine too. The math is no different. And if doing things in smaller steps will help you, do that. Whatever makes this problem easier and easier for you to understand is how you should be doing it. But make sure you don't forget to include the 400,000 or whatever value that initial expense is, because the NPV function does not look at the year 0 cash flows. And we've solved the question. We now know, thanks to the NPV function and a little bit extra, that our net present value is a positive 33,000. Sometimes this is all you need. The question will just ask you, what's the net present value? And with this 33,000, we would be done. However, many times we professors are going to ask you, how do we interpret the net present value? And it's very straightforward with pretty much every decision rule, really, but it's very straightforward for net present value. We just say, is it greater than 0 or is it less than 0? And of course, 33,000 is greater than 0. I should hope you don't need Excel to tell you that. And although you could set up a function to do that. And since it's greater than 0, this is a good project. McKee Inc. should build a warehouse. They will effectively earn $33,000 in today's dollars the moment they decide to build the warehouse. In reality, they'll receive the cash flow later in time. But in present value terms, it's going to add cash to my company. So I should do it. Since we used cell references to calculate NPV, I can apply this spreadsheet to any other NPV question. I'll have potentially a different set of cash flows. I'll just change my timeline. I might have to change my array to include extra years or take off years if it's a shorter than 5 years or longer than 5 years. And I would just need to change my interest rate if the WACC for our project in the new question is different from the project that I have just shown here. But all you have to do is just modify your timeline and modify your WACC, possibly do a few quick edits over here, and you will have your NPV again. So with this single function, you can now find the NPV for any question your professor might throw at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find this too. Happy study!